Okay. So good afternoon, sir. Sir, I'm Ritrajpal, and I will be discussing this uh, hard DP problem. That is, the statement of the problem is we have been given n jobs, and we have been given two array, that is a start time and end time, which basically specify the start time of the job and end time of the job. And there is also another array, that is profit array, which basically specify that if we will perform the ith job, then we will earn the ith profit, right? So these are the three array that we have been given, and we need to find the maximum profit that we can earn after performing the certain number of the job. But the condition is that no two jobs should be overlapping. Okay, so let's understand this statement via an example. Let's talk about the first example here. The first example is, if we'll talk about the start time, that is 1 2 3 3, right? And if we'll talk about the end time, that is 3 4 5 6. So what does this mean? This means that the first job, which lie at the 0th index, will start at the 1 and will end at the 3, right? And the second job, which will start at the 2 and will end at 4. The third job, which will start at 3 and will end at 5. And the fourth job, which will start at 3 and will end at 6, right? And if we'll talk about the profit, then if we'll perform the first job, then we'll earn the profit of 50. And if we'll perform the second job, then we'll earn the profit of 10. And if we will perform the third job, then we'll earn the profit of 40. And if we'll perform the fourth job, then we'll earn the profit of 20. So this is the problem statement, and in this case we'll need to find the maximum profit that we can earn after performing this task, such that no two tasks should be overlapping. So this is the statement that I think that we have understood, right? So let's see the first example. In first example, they are saying that they will select the first job and the fourth job, right? If we select the first job, whose starting time is 1 and ending time is 3, right? So it will end at 3. And if we will perform the fourth job, whose starting time is 3 and ending time is 6, then yeah, the first job is will perform between the 1 and 3, and then fourth job will perform between the 3 and 6. Then we can clearly see these two jobs are not overlapping to each other. So yeah, we have chosen the valid job, right? So yeah, these two jobs can be performed, and we can earn the profit of 50 plus 70, that is 120 in this case, and which I think the maximum one we can get. And like, can we perform another possibilities, another set of possibilities? Can we pick the first job or third job here? So let's see what will happen. We'll please pick the first job and third job instead of fourth one. So if we'll pick the first job, then its starting time is 1, right? And ending time is 3. While the starting time of third job is 3 and ending time is 5. So yeah, these two jobs are valid, and we can perform these two jobs because they are not overlapping. And let's see about the profit that we can earn by performing these two jobs. And uh, can we perform another job? I mean, if I will perform the first job and then third job, and then can we perform the fourth job? No, we can't perform, because if we perform the fourth job, then clearly we can see the third one is ending at 5 while fourth one is starting at 3, right? So it is not validating the rules of the jobs, no, because the jobs should be non-overlapping to each other, right? So we can, if we are choosing to perform the 3 with 1, then we can't choose the fourth one along with 1, right? So this is the possibilities that we can choose the 1 and 3. If we'll choose any other jobs along with them, then we will not validate the rules of the job performance, like the way the job should perform, right? So let's see the profit that we can earn after performing the first and third job, that is 50 plus 40, which is equal to 90, and which is smaller than 120. So can we perform any other another set of the jobs? Let's see. Can we perform the second job? The starting time of the second job is 2, right? While ending time of the second job is 4. Okay. Or can we perform any another job if I am performing the second job first? Can we perform the third one? No, we can't perform because it is not validating the rules of the job performance, right? The third job should be starting time of the third job should be greater than equal to 4. Then only we can perform the job. One more statement that I want to tell you. Read this statement. In this statement, it has been given that if you chose a job that end at a time x, you will be able to start another job that start at time x. Let's say if I am ending a particular job at 5, then another job can be starting at the 5 as well. These two are not overlapping. They are validating the rule of job performance, right? So yeah, this thing we can do. So I think you have understood the problem. So let's copy paste this test case here in the doc. Okay. Okay, let me write it manually. Start time is 1 2 3 3. Start time start time. Okay, let me do it totally white or what. Okay, now I think copy paste as well. Oh, okay. Let me do it. Okay, yeah, it should be black now. Start time is, let's say start time is, what was the start timing? Start timing was 1 2 3 3. 1 comma 2 comma 3 comma 3. Okay, so these are the start timing, and end timing is end time start time. No, it was a start time, and then it is just end time. Okay, and that is basically what is the end time. End time is 3 4 5 6. Okay, 3 4 5 and then 6. Okay, this is the end time. And let's talk about the profit, that is 5 50 10 40 70. Profit is 50 comma 10 comma 40 comma 70. Okay, so these are the data that is given to us, right? And we have talked that if we will choose the first and the final of job, then we are going to get the maximum profit, and that is 120, right? And that is the maximum profit that we can earn. Okay, so, and like we have chosen the another job as well, we have performed the possibilities of choosing the first job and third job as well, but in that case we are getting the profit that is equal to 50 plus 40, that is equal to 90, and which is not the maximum of like which is not greater than 120. So 120 is the final answer. And if we will choose the first and second job, like we can't choose the first and second job because they will be overlapping, because the first job is ending at 3 while the second job is starting at 2, right? So basically these two jobs are overlapping, so like they are not validating the rules of the job performance, right? So like we can't perform the these two jobs concurrently, like along with they can't be performed together. So yeah, and like one more possibility that we have discussed, that is if we will perform the second job, then we can't perform any other job, because if we will do so, then we are not validating the rules of the job performance. That is fine. So basically we are covering the every possibilities, right? Can we do this job or can we not do this job? So these are the two possibilities. So basically if I am at any index I, let's say this is if I'm at any index I, then at that particular index I'll be performing whether to perform that task, or whether to perform that task or move to the next one. So these are the possibilities that we will be performing if I am at the any index I, right? So if I am at the any index I will pick this job or I will skip this job, right? So these are the two possibilities that we are going to do for every index I. Okay, so here we can see that we have the choices, so we can do dynamic programming. We can write the recursion and then we can memorize the recursion, right? So yeah, so this is the overall uh, catch of the problem, that we can use the dynamic programming that we have that I have said initially, that I will be recording this. This is basically a dynamic programming problem. Okay, so what was the catch that we have built? What is the basically intuition that we have built? We have built that for every index I, we will be performing two type of operation, whether to pick that particular job or to skip that particular job. Okay, so but how? Okay, so one more thing that I want to tell you is that, let's say I have picked the job 0. Basically job 0 means the job at the index 0. So that will start at 1 and will end at 3. Okay, so can we pick the third job? Yes, we can pick. Can we pick the second job? No, we can't pick. So basically, if I have picked a particular job, then we will be finding any job whose starting time is greater than equal to the end time of the last picked job. So basically the last picked job in this case is job 0, whose end time is 3, right? So I'll be finding the any job whose starting time is greater than equal to 3, right? That I will be finding. So in this case I am getting the job 2. Yeah, we can pick the job 2 as well, and we can also pick the job 3, because starting time of job 3 is also greater than equal to 3, and obviously the ending time of that particular job will be greater than equal to its starting time, right? So yeah, this thing we can do. But how we can find this job, this thing, that uh, if I have picked this job, then where to jump? Whether do I need to jump IND plus 1? What could be the case that if I will skip that particular job, then I will jump to the IND plus 1. And another case is that I can jump to the any appropriate index. Basically appropriate index in this case is the job whose starting time is greater than equal to the end time of the current job that I have picked, right? So like how we can do this thing? One thing that is striking in my head is that we can sort this array. Like first of all, we'll take one array, basically let's say that is job array, and that will basically store this thing, the start time and end time, that is 1 comma 3 of the jobs, right? So another is let me do this thing. Another is 2 comma 4. Another one is 3 comma 5. Okay, 3 comma 5. And another one is let me okay, another one is 3 comma 6. 3 comma 6. Okay, so these are the job. Basically we know the starting time and end time of the job, and we have sorted, right? So let's say will we every time if I am picking that particular job, let's say if I have picked the job at the 0th index, then I should jump to the job at the 2nd index, and this thing we can find with the help of lower bound. So we'll always apply the lower bound on this start time, right? This start time, and which will be basically sorted, and we'll try to find the lower bound of this job of the first index of ith first. So let's say this is the 0th index and this is the first index of the job array. So I will be finding the lower bound of this first index of the job array in start time, and basically and in this way we will be finding the appropriate index, and then we'll jump to that particular index we have if we have picked that particular job. So let's say if I have picked the 0th index job, right? Then we can jump to second index job by finding the job whose starting time is greater than the end time of the job which we have picked, right? So and this we can do with the help of binary search. Okay. And one more thing that we have discussed, that we will be performing for every index we will be performing peak not peak operation, right? And covering all the possibilities and exploring all the possibilities, right? Okay. Sorry for the spelling. Okay. Possibilities, TIES. Okay, so this is the first intuition and this is the second intuition. So basically we will be using dynamic programming plus binary search method to solve this problem. So this is the overall intuition of the problem, right? I think it is enough to build the intuition. Okay, so let's now let's quickly code this here. Okay. Okay, so let's say int max profit is the function that I will be writing. Okay, so what are the things that we will be mentioning here? The thing is that we are basically iterating over the index, right? So surely we'll take that particular index. Okay, and another thing is that we need to take that particular vector, this job vector, right? Job vector which will basically contains the start time of I and end time of I, and that is basically sorted in order. So I will also take that particular vector of int and job. And another thing is that we also need a start time and start time. Let's take this thing start time. Okay, and another thing is that do we need to take the, yeah, we can also take any here, and yeah, so these are the things. Okay, so like I will be covering the base case later, right? So if I am picking the job at the index IND, then where do I need to jump? We need to jump to the appropriate index, and basically the appropriate index is whose starting time is greater than equal to the ending time of the pick job, right? So I will be finding the next index of the job that is equal to lower bound of start time of I, okay, so like I will be start time dot begin. Okay, so let's build this array that we have talked about. So vector int jobs, right? And then I will be iterating over the int is equal to 0, I less than start time. Okay, let me copy paste here to see. Control V dot size I plus equal this, and then jobs dot pushback start time of I comma end time of I. And then let's quickly sort this. Jobs dot begin comma jobs dot end. Okay, let's quickly sort this. Okay, and then what else we can do is that yeah, one more thing that we need to do is that we will be finding the next index on the start time array, right? So yeah, one more thing, we can do this thing, I equal 0, I less than start time dot size I plus equal this, and then since this jobs array is sorted on the basis of a start time of I, then we can do these things easily, I comma 0, right? So this start time which is basically containing the the value which is sorted, right? Like jobs of I comma 0. Yeah, now I have basically built this array. Okay, so on this array only, control v dot n, I'll be finding the which I need to find this job of ind comma 1 minus start time dot begin. So in this case we can in this way we can find the next index. So what are the possibility that we have discussed is that either we can skip the particular index job, so in that case I will be earning the 0 profit, so directly move to the next index. Okay, and d plus 1 and then job. Okay, then job and then this start time then n. Fine. Or like we can take okay, so like I also need to take profit array, right? So if I'm picking the job at the ith index, then I will take the profit, and then okay, here max profit, this is the function here with 0 plus max profit, and then profit of ind plus max profit of where do I need to go? I will just jump to the next index. Okay, and then job will be as it is, and then start time will be as it is, start time, right? Start time will be as it is, and then n, and then profit. Okay, so yeah, and then I will be just returning the maximum of these two, skip comma take. Okay, and in the best case if and is out of bound, then in that case I will be returning 0. I don't need to return anything, return 0. And yeah, so these are the things that we can do. And the maximum intake, the maximum profit of 0 comma this jobs comma the start time, fine, yeah, and then yeah, then profit, we need to pass the profit as well. Okay, so return think is to run fine or what? Let me run it. Skip. Okay, here I need to include this profit array as well. Okay, so int is equal to okay, and then I will write here n. Okay. Yeah, this thing is working fine, right? So if we'll talk about the complexity of this recursion, then what is the complexity? The complexity would be like I'm performing the two type operation, right, at the ith index. Either I will pick this or I will not pick this. If I am picking, then I will jump to the next index. If I'm not picking, then I will jump to the and d plus 1, right? So like for every index I'm performing those two type of possibilities. So for n index, the overall time complexity will be 2 raised to power n, right? For the where n is the total length of the array. And since we are also performing this binary search, then for that it could be log n. And if we'll talk about the space complexity will be we are using the recursion take stack, recursion stack. So for that, since we are making the recursion of 2 to the power n times, so like there will be 2 to the power n recursion call. So space complexity will be something around that also. So I think this is not acceptable, because if you'll see the constraint, then constraint in this case is 5 into 1 is 4, right? And which is not the good solution. So we need to optimize it. How we can do? We can memorize this recursion, and then it will run fine. So if we'll run this code, let's see, submit this code, then we are going to get TLE, because the complexity is 2i and we need to memorize the things. Okay, so like we are getting the wrong answer here. Why we are getting wrong answer here? Uh, why we are getting wrong answer here? Uh, okay, skip is 0 plus max profit of this. Oh, okay, and a plus 1, and then job start time n profit. Okay, that is fine. And then profit of Andy. Let me do this thing. Profit of I. Okay, and then there is no need to pass. I think there is no wrong with this, but still it is more efficient. So take plus job of Andy comma 2. Yeah, that should be there now. We are also getting more value, right? 9 instead of 7. Yeah, that should run fine, and it should give the maximum of skip comma uh, take. Yeah, that is fine. Job here is equal to start dot size, and then okay, that is fine. Profit of I, and then job dot begin, job dot end, and then I comma 0, I end dot size, that is also fine. No problem. Jobs of I comma 0. Yeah, we are basically taking the 0th index, and then yeah, it should now run properly, right? So let's erase this thing as well from here. Profit, yeah, let's erase this, and let's erase this as well. It should be n. Okay, and let me run this. It is giving correct, but why it is giving wrong here? Yeah, now we can see whether it is giving TLE or wrong answer. If it is giving wrong, then we need to do something correct. If it is giving TLE, then we need to memorize. Yeah, we are getting time limit exceeded at test case 18 out of 35. So let's say, let's memorize this recursion. That is, yeah, since we have only one thing that is varying, and that is index. So yeah, I'll be taking the dp of size and comma, no, it should be n, na? It should be n, basically the 1d dp, and let's initialize it with -1, and then simply pass it here as well, and let's copy it and then paste it here directly. It will run fine. And then another case is that if dp of ind is not equal to -1, then we'll be just returning the value. Okay, we'll be just return the value, return the dp of ind. Okay, and here also we can do dp of ind. Dp of ind is equal to maximum of this, and then here just pass the dp array as well in each and every function, right? Yeah, now I think it should run fine. It should run fine. Yeah, it is running fine. Let's use this test case as well, and we'll check if it is running fine or not. Yeah, it is running fine. And now the time, if we'll talk about the time complexity, then we have used the dp vector. So for that, if we'll talk about the time complexity, then it is directly reduced to time complexity. It is directly reduced to n star log n, right? Log n for we are iterating over the every index, and log n for binary search. And if we'll talk about the space complexity, then its space complexity is simply big of n for what? For dp plus another big of n for recursion stack, recursion call, and we are also using n into 3 for that particular array, job array, right? So for that also the time complexity will be n into 3. So if we just normalize it, then overall time complexity will be big of n. Okay, so in worst case the time complexity, that was a space complexity big of n, and the time complexity is n log n. So yeah, this is about this problem. Let's quickly submit this problem. Okay, so we are getting the accepted one, right? So yeah, this is all about this problem. Thank you.